Assalamu alaikum, this is Imran Hussain, and today we're going to talk about MongoDB. Mongo is one of the most popular NoSQL database out there, if it is not the most popular one. It is really powerful with great performance and is really handy and easy to use. Unlike SQL databases, you are not gonna have tables here with fixed schemas, fixed columns and etc. You will have collections instead, where you are gonna save your data, where each row is called a document. Think of each of this row, each document like a blob of data, okay? Like a JSON object to be more precise. One of the most beautiful things about this architecture, which may turn out to be a little problematic sometimes, is that not all the document under a collection need to have the same number of properties. I got this JSON file which contains about 0.1 million of tweets. And let's go to the properties and let's see. It's about 453 megabyte. It's a text file. It's a JSON file. It contains text only. So I'm gonna import those tweets in my Mongo database. To import that, first you'll have to have MongoDB installed in your computer, and it's really easy. You just head over to Mongo's site, through the download section, and go to server and download the MongoDB server in your computer. After downloading it, you're gonna have it running in your task. You can go to your task manager and go to services, and you can see Mongo server is running there. And to browse your database, you can install a software called MongoDB Compass, and it has a community version which is free. So, and it is really good. It's beautiful in the software. So I have MongoDB installed, I have MongoDB Compass, and now what I'm gonna do is I'm gonna import the tweets.json file, which contains a lot of tweets, in my database. So I don't have any table named tweets. I don't know which fields are there and what are the data types of those fields. I really don't know, and the beautiful thing about MongoDB is I don't have to know. Okay, I can just go to the installation folder of MongoDB, that is in CRI program files, and where is my MongoDB, and go into server, then 4.2 bin. Okay, as you can see, it has a lot of tools here. Then there is mongo.exe, mongo export, mongo dump, mongo import. All of them has different functionalities. Like with mongo export, you can export your data. Mongo dump is like you can dump your data somewhere. And with mongo import, as the name says, the name is self-explanatory. You can import data with it. So just hit CMD here, and then it's really simple to import, So we're gonna be using Mongo import here. Mongo import is a command line tool with which we can import data from a file or any other source to MongoDB. Okay, and it's really simple. We'll just have to write Mongo import. It's important that you are in your command line, you are in here, otherwise it's not gonna know where your Mongo import is. Okay, as I haven't added it to my path variable yet. So let's write Mongo import. Then I'll have to give the name of the DB, which is gonna be test. In this case, then in these databases, our Mongo database can have many collections, and so I'll give in the name of the collection, which is like tweets. Then I'm gonna import from a file, and which is I'll have to give the path of the file. Then I'll have to put the name of the file here along with the path. So I'm copying it. Then okay, elastic / tweets.json. Okay, if I just hit enter now, it will import those data to my MongoDB, but I have already done it before, so I'm not going to do it this time. Okay, so let's head over to MongoDB Compass. Okay, there is a test database, and there is the tweet collection here. So let's go in. As you can see, these are the rows. Okay, it's only showing 20 rows here, and it has got many. Okay, I'm not gonna count. So as you can see, the first one has for the first one it says show 2 more fields. For the second one it it says show 1 more fields, then it says show 4 more fields, then 2 more fields, show 6 more fields. It means that not all the tweets, I mean all the documents here, have the same number of properties. Okay, so the fields are, there can be different fields with different values. Not all of them are bound to have the same number of properties. It's beautiful. Okay, so we have got all our tweets imported here. So I'm gonna show you how to do different things on them, just like you used to do on SQL databases. Okay, so let's say I want to find out all the tweets which are in reply to user ID this. Okay, so for this I'm gonna have to use the filter. So in filter I'm gonna write my query, which is in reply to user ID, then I'm going to give the value. Then if I click on find, okay, yeah, there's the only tweet is this. Okay, there's a user in here whose screen name is globe and mail. Let's say I want to find every tweet which is here in reply to that user. In reply to CRWN screen name, as it is a string, I'm gonna put this comma here, globe and mail. Just click on find. Yep, as you can see, all these tweets are in reply to that particular user. Okay, then yeah, it is really simple. As you can see, there are several filters here. You can write, you can find anything you want. Let's say you want to find you know, where the ID is, where the user ID is this, all the tweets made by this user. In that case, you're just gonna have to write user.id, and you can put the ID in here. If you click on find, it's gonna find all the tweets of that user. It's really easy, and just like object-oriented languages, you can just go into nested objects with dot. So this was all about filter. Filtering is really easy, and I don't think I'll have to show you in details how to use that. It's just like the where query we used to use in SQL databases. So let's move on to aggregations. Okay, aggregations are a bit more difficult, but they're not actually difficult. You know, they're really simple. Let's say I want to find out every user with the number of the tweets, and let's say my user ID is 1234 and I have tweeted 17 times. So I want to find that and list those users along with their number of tweets in descending order. Okay, let's do that. So there is an aggregation called group aggregation. I'm gonna do that here as I want to find those users which have tweeted, and along with their number of along with their count of tweets, you know. So I'm gonna group by those users. This group aggregations comes with first, for using the group aggregations, I'll have to first define based on which field I'm gonna be doing the group operation. So the ID here is the key of that group. So this is gonna be the user ID. Okay, I'm gonna give it a name. Let's say user, and this is gonna be the user.id field, as this is an object in that in our document. I'm gonna put a $sign before user.id. Okay, what this is gonna do is give us back a collection where the key is user ID, and with that an array or a collection that contains all the tweets by that user ID. As you have already seen from the document, that each tweet object contains an user object which contains the user himself. So this aggregation here is going to return us with a number of tweets, all of which contains a user object, the user who tweeted the tweet. So we are going to take the first user from there, to get the user himself, you know. So I'm gonna name it user, and this is gonna be, here we are gonna apply aggregation function, which is first in the sense that it is going to be in the it's going to be the first item in the collection that this key contains. Okay, so this will be $user, the first user object of that collection. Then, as I have already said, I want to find the number of times the user has tweeted. Okay, so what we are going to do here is, as this is a group by like query, we're gonna have to use another aggregated function. So for the count thing, I'm gonna use another field which I'm gonna call count, and let's say I'm gonna use another aggregated function here, which is gonna be sum. Okay, which is gonna be sum. Okay, so let me explain a bit here what is happening. This ID is gonna group all the tweets under each user's ID. Okay, then on that collection, what we are gonna do is we are gonna take the first user in that collection, first user object in that collection, then we are gonna do a sum operation. Okay, and this sum is just like the one we have used in SQL databases. Like if we are making a database of a shop, then that shop has products on different categories. So let's say we're gonna have to find the sum of the prices of all the products under a category. Then what we could do is group by all those products with their category ID, and then we could do a sum operation on the prices of those items, but which is the same here. Okay, that's the same operation here, but we don't have a price or any other field with each tweet. Okay, so what I'm gonna do is I'm gonna put a value, a hard-coded value called 1. Okay, I'm gonna give it a value 1. So what it is gonna do is for each item in the collection, it's gonna do a sum taking each tweet's value as 1. Okay, so if a user's ID collection has 5 tweets, for each tweet we are gonna get the value 1, and we are gonna do the count, so we are gonna get 4, the result we are asking for. As you can already see on the right, MongoDB Compass already shows you the result of your query, which is like the ID, the user ID is this, and the user himself is this, Ryan Robinson. This user has tweeted 3 times. Then there is this ID, which is the user ID. The user is Brad Saxton, and he has tweeted once only. Okay, so let's say I wanna sort it. Okay, you can't do sort in group, I think, so I'm gonna use another stage, then use the sort thing here. Okay, I'm gonna use sort, which is gonna be on the count field, and it is gonna be descending order sort, so it's gonna be -1. So okay, we've got a result. This is our final result. So our user LN on retweets or something, this user has tweeted 2,540 times. Then this user who is on the second place, he has tweeted 925 times. So this is how aggregations work. Neat, right? So let's do it again. Let's say we want to produce a list of what do we have in this document? Place. Okay, we're gonna produce a list of tweets along with their place names. Okay, so we're gonna find out that from each place how many tweets are being made. Okay, and we're gonna need the count of those tweets as well. So let's go there, write place, then say place.id, and first of the place thing. Okay, I've changed it, so this is the result. I've got it already. Instead of user, let's call it place. Yep, so the first is the place with this ID, and the name of the place is Michigan. So the highest number of tweets were made from Michigan, and the second best is the Ottawa in Canada. They did about 10,000 less tweets. 7,000 less tweets than Michigan. So that's how you do aggregation, folks. In my aggregation pipeline here, first I have put the group operation, then I have put the sort operation. Okay, so my aggregation pipeline here consists of two operations. Let's say I want to do a more complex aggregation with more things to do. What can be that? Create our aggregation skill, where we are going to be writing a little more complex aggregation queries, and there are going to be a few more number of elements in our pipeline. Let's say what we're going to do is produce a list of users with the total number of replies to that user. Okay, as we already know, tweets can be made in reply to a specific user. Let's say in this case, this tweet was in reply to this user. Okay, so what we are going to do is find a list of users along with the number of tweets against that user. Okay, so let's head over there, clear this clutter, and add a stage. First, what we're going to do is there are many tweets which are just normal tweets. They are not in reply to anyone, so we are going to filter those out. So what I'm going to do here is match, and then I'm going to write here in reply to user ID, and this cannot be equal to null. Okay, so I'm gonna use the function NE, which means not equal null. So it already shows the result because our query here is right. It's showing us the tweets which are in reply to someone. Okay, so our match query is done in the pipeline. Then I'm gonna use a group by on here. Okay, then use group. The ID here is gonna be in reply to user ID. Okay, in reply to user ID, and I want to find the count, which is gonna be just like before, the sum of 1. Wow, it's already showing results, so our query is right. Then I'm gonna do a little bit of sorting. Sort, and here I'm gonna write count, and this is gonna be -1, so in descending order. So in our list, the top is this user who has been replied to 206 times, but I'm not having the user himself here, right? So let's introduce another problem here. It was pretty simple, right? But let's introduce another problem here. Let's say I want to see the user to whom this tweet was replied. Okay, the problem here is, in our documents we have a user object which contains the user who made that tweet, but not the user to whom it was replied. Okay, So we only have the ID of that user to whom it was replied. We will have to get the user in a different way. Okay, so what we can do here, as we've used SQL databases before, we know that we can use join, but here we don't have join. What we have here is a better thing, and it's not better, it's a different thing, that's called lookup. So let's use lookup. I'm gonna use another stage in our pipeline, which is gonna be called lookup. Lookup has different things. Let's say from we are gonna have to give a name of the collection with which we are gonna join it. So we are gonna self join. So the name is gonna be tweets, and then I'm gonna be joining it with the ID field, right? So the local field is gonna be taken from our pipeline. I was calling it ID before, underscore ID. So our local field is gonna be underscore ID. Then this is the foreign field. This foreign field here is a name of a property of the field we're joining with. Okay, so we're joining with ourselves. I mean the tweets collection. So the name here is the user.id because we want to get the ID of the user. Okay, and we're gonna get the output as US, or let's say, you can see this user whose name is M. Marcotte. He had about 180 tweets in reply to him, and this user object's ID matches with this ID. So yeah, we've done it, right? Cool. And so as we have already used aggregation, as you can see that it is really powerful, but there are cases where we can be in need of more powerful things. For that, Mongo has introduced another thing which is called MapReduce. MapReduce is the same thing as we have seen with Hadoop and other stuff. So let's talk about how MapReduce works. Okay, let's head to Mongo's official documentation here. I've already kept it open. Okay, what it does is this is the name of the database, this is the name of the collection, and on that we are going to use the Mongo's MapReduce function. MapReduce function takes a few things in, like the map function, the reduce function, and then another function where you can write the query and what's the name of the output going to be. So is first it runs the query on a collection, then on the output it runs the map function you have written here. I mean not on the collection, on each of the document or each of the item of the collection it runs the map function, and then the map function emits a group by like key value output. Okay, then it runs the reduce function which I've given on those outputs which has multiple collections or multiple values to a single key. Okay, in here in this example they have this collection of orders where the status is A and D. First we want to take those orders which have a status of A, and it has taken 3 out of the 4. On those items we are gonna run the map function. Let's say the map function says emit this customer ID, which is the key, and then this is the amount. Here we can see in this collection that 2 of this customer ID matches. What this map function is going to do is going to do something like a group by operation and those keys together, and the values are going to be there. I mean this value is going to be there like an array or like a collection under that key. Okay, and what the reduce function does is takes in as input from the output of the map function and then does what you have told it here to do. Most beautiful thing about MapReduce is you can write any valid JavaScript here. So the power is in your hands now. As you can see in this reduce function, it takes in those key and values and then it returns the sum of these values, okay? So after it takes in the A123 value, then the values is 500 and 250. It does the sum and returns you the value. So the ID is gonna be the ID, I mean the key, which is A123, and the value is going to be 750. In this case, the reduce function is not going to be applied on here as it has only one value. The reduce function only works on multiple values. So yeah, this is going to be your final output, and which is going to have the name or the totals which you have given here. So let's use this knowledge to do something here. So let's head back to MongoDB Compass here. The problem with MongoDB Compass is I haven't found a way to write MapReduce queries here. So what I'm going to do is write the MapReduce query in MongoDB's shell. Okay, so how to run the shell? I'm going to be heading to the bin. Okay, I'm going to write cmd here, and I'm going to write mongo here. So this is the shell, our neat, tidy shell. So let's find a problem for us to solve first. Let's head back to the MongoDB Compass and let's see. Okay, we can see that some of the tweets have hashtags. Okay, so what Twitter does is it puts those hashtags in a different field. Okay, in entities, then in hashtags. Then you can see the arrangement. This is on hashtags, which is there in the text. Okay, so what it does is it puts those hashtags, multiple hashtags, in an array. So let's say what we are going to do is we are going to find each hashtag from every tweet and see how many times that hashtag has been used. Okay, so let's write the function. This is just a plain old JavaScript function. Let's say for a tag of, this is a simple for loop JavaScript style for loop of this. The first one is the map function. This map function is going to run on every document that the query function outputs. Okay, so it is going to run on each and every document, and every document is going to be referred to as this. Okay, so this dot entities, 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 and as you have already seen in MongoDB Compass that entities have hashtags. So for each hashtag we are gonna emit the tag dot text. Let's go there, and as you can see, this tag, this hashtag for each object in the hashtag field, hashtag array, it has a text property. So we are gonna emit that text property as our key. Okay, and the value is gonna be 1. So each of them is gonna have a value of 1. So the key is gonna be the text, and that key will have an array of ones where each one will denote a single time where this hashtag was used. I'm gonna be a good boy and put a semicolon there, and this is our okay, this is the map function. Then I'm gonna write the reduce function. This reduce function takes 2 fields, like the key and the value. So I'm gonna name it age tag and the count as CNT count. Then I'm gonna return from here return array dot sum CNT. Okay, I'm gonna be a good boy and put a semicolon again, and then I don't have a query here. I'm gonna take all the all the documents. So I'm not going to write a query, but I want to name the output as something. So out as ABC. This is a string, so this, and then after the whole MapReduce function, I'm gonna call find so that it shows me the output. So I'm gonna press enter now, and it's gonna take a while. 1 2 3. Okay, here's the output, and as you can see that this is the top. Okay, now this is not the top as we haven't sorted it, but the thing is the output here is this 1000 likes hashtag have a value of 2, that means this hashtag was used twice. Then 12 days of cleaning has the value of 51, so this hashtag was used 51 times. And 12 monkeys was used twice. This 100 mad was used once in all of our collection. So this is how you use MapReduce. It's pretty handy, right? And you can do a lot of things with it. If you have any questions or if you have any queries regarding MongoDB, or any query you are having a problem with, you can just put it under in the comment section. And don't forget to subscribe and share. Thank you.